This is Math 2, Unit 5, Lesson 2, Notes 5.2, and the title is Properties of Parallelograms. First one. The first one is actually the definition, and that is that opposite sides are parallel. And both sets of opposite sides, not just one, not at least one, both sets of opposite sides are parallel. If that happens, then we'd call the image, the polygon, a parallelogram. Now, parallelograms are quadrilaterals, meaning they're polygons with 4 sides, and opposite sides are always parallel. Okay, so really quick side note, this is also the definition of a parallelogram. When you see this symbol there, that's just shorthand for parallelogram. Just like we draw the picture of a triangle instead of writing out triangle every single time, there's what we're going to write for a parallelogram. Okay, number 2. Opposite, this is a property, opposite sides are congruent. If it is a parallelogram, meaning it's a quadrilateral where both sets of opposite sides are parallel, then every single time opposite sides will be congruent. Not all 4 sides, opposite sides. We do have a special name when all 4 sides are congruent, but that will be another day. For now, general parallelograms, opposite sides are always congruent. Number 3, opposite angles are congruent. So not only the opposite sides, like number 2, but also opposite angles. Opposite angles are diagonal across from each other. They do not share a side. So I would say that this angle is equal to its opposite angle. Do you see this angle has those 2 sides as an angle? This angle has those 2, but they do not share a side. This angle is congruent to its opposite angle. Okay, so opposite sides are congruent, opposite angles are congruent. This happens every time we have a parallelogram. Another thing is something with consecutive angles. And what are consecutive angles? Well, they're not opposite because we have a name for that already. Consecutive angles are ones that share a side. So like those 2 there, that's consecutive. They're next to each other, those 2 there. That's consecutive because they share a side. Or even those 2 up there are consecutive because they share a side. Or these 2 at the bottom, consecutive because they share a side. And consecutive angles are not congruent, they are supplementary. Remember that supplementary means they add up to 180. Okay, so consecutive are not opposite, they're not across from each other, they are on the same side. In other words, they share a side. So anytime you have a parallelogram, consecutive angles will always add up to 180. So I'm going to label this 1, 2, 3, 4. Angle 1, angle 2, angle 3, angle 4. And over here on the side, I'm going to quickly review with you. We've talked about this before when you have, it was like the first week of school, parallel lines cut by a transversal. We talked about the Z shape, the F shape, the C shape. This one we're going to talk about right now is the C shape. If the arms of your C are parallel, then these here, those angles there are supplementary. They add up to 180. If the arms of your C are parallel, those little corners there add up to 180. We've talked about that before. So you can say that angle 1 plus angle 2 equals 180 degrees. But 2 is also consecutive with 3. So you can say angle 2 plus angle 3 equals 180. Well, if 1 plus 2 is 180 and 3 plus 2 is also 180, that means that those 2 angles must be the same, which is true. Angle 1 is opposite angle 3. They are congruent. Okay, another set is angle 3 plus angle 4. That's those two there. Also add up to 180. And there's one more set. What is it? Angle 4 plus angle 1 equals 180 degrees. All right, so you will need to know this. You will need to know that opposite angles are congruent, opposite sides are congruent, and of course the definition you learned back in elementary school, opposite sides are parallel, both sets of opposite sides. Okay, number 5, another one you will need to know is that diagonals, something about the diagonals. Diagonals bisect each other. They're not congruent, but they do bisect each other. So, if you have a parallelogram, then we know the diagonals bisect each other. So diagonals go from one angle to its opposite, so like that, that's a diagonal. And across this angle to its opposite, that's a diagonal. Now, this diagonal is not congruent to this diagonal. There is a special image where that does happen, a special parallelogram, but we're not doing that today. Today we're talking about all parallelograms. So in all parallelograms, this side will not always be equal to that. So the diagonals are not equal, but they do bisect, meaning they do cut each other in half. So this smaller diagonal cuts the bigger one in half, and this bigger diagonal cuts this little tiny one, or smaller one, in half. So you have these two that are congruent, and those two that are congruent, not all four, but those two and those two. Again, in a few days we'll have one where they are all congruent. Not yet. Okay, so those are the properties you will need to know. A really quick side note, it's kind of a combination of them. Go ahead and draw your parallelogram. If one set of opposite sides are parallel, so all they're telling us is one set is parallel. I'm going to give you more information, but not anything about this side. So if I just stopped here and just said that set right there is parallel, is that enough to say it's a parallelogram? No, because definition, both sets have to be parallel. So saying just one set is not enough. But if I gave you more information, so if one set of opposite sides are parallel and congruent at the same time, then it is a parallelogram. So on assignments, on a quiz or a test, they'll give you something like this and say, is this a parallelogram? Yes or no, and explain why. You would say yes, because opposite sides are congruent. Yes, because opposite angles are congruent. They may give you something like this, and you would say yes, because consecutive angles are supplementary, or they most likely give you numbers in here. And as long as consecutive angles add up to 180, you would say yes. Here, you would say yes, because diagonals bisect each other. Now, if they give you an image just like this, and that's it. No, there's not enough information. We don't know if those two lines are parallel. But if the image looks like this, where one set is parallel and congruent at the same time, then yes, you can say it is a parallelogram. Okay, that is it for this lesson. Oh, really quick, these can go either way. It could be top and bottom, or it could be right and left. It doesn't matter. As long as one set is parallel and congruent, then it is a parallelogram. All right, that is it for this lesson.